Hello everyone. Today we are going to talk about physics at grade 9 level, and we are going to see the third part of the topic motion. We are going to see VT graphs. In our previous lessons on motion, we saw scalars and vectors quantities, distance and displacement, speed, velocity, acceleration, and deceleration. The main topic for today's lesson is speed-time graphs. In this topic, we are going to see the types of speed-time graphs, how to interpret speed-time graphs, how to calculate distance from speed-time graphs, how to calculate acceleration and deceleration from speed-time graphs. Speed-time graph. The speed-time graph is a graph that shows how the speed of a body is changing with time. Speed-time graph is drawn with speed on the vertical axis and time on the horizontal axis. Sketching speed-time graph. For sketching the speed-time graph, we need two sets of values. These values are time and speed, that is, speed at various intervals of time. Sketching speed-time graph using data from a table. In the table, we have value of speed at various time intervals. We are going to use these data to sketch a speed-time graph. We start by drawing the time and the speed axis. Then we place the values of time shown in the table on the time axis. The same thing is done with values of speed shown in the table. Now we represent each pair of time and speed values on the graph with a cross. After that, we draw a line that connects one cross to the next cross as shown here. This is done for all crosses. Finally, we have our speed-time graph. Types of speed-time graphs. Example 1. An object which is at rest. This means the speed of the object is 0 at all times. The speed-time graph for an object which is at rest is a horizontal line on the time axis. Example 2. An object moving with constant speed. The speed of the object remains the same at all times. The graph is a horizontal line parallel to the time axis. Since speed is remaining the same, acceleration is 0. Here we have an example of an object that is moving with constant speed of 40 meters per second for 10 seconds. The graph is a horizontal line. Example 3. An object moving with increasing speed. For example, the speed of an object increases from 0 meter per second to 25 meters per second in 10 seconds. The speed-time graph of such an object is a line with an upward inclination. We say the body has a constant acceleration. Example 4. An object moving with decreasing speed. For example, the speed of an object decreases from 40 meters per second to 0 meter per second in 10 seconds. The speed-time graph of such an object is a line with a downward inclination. We say the body has a constant deceleration. Calculating the distance covered by a body from its speed-time graph. The distance of a body can be obtained by calculating the area under its speed-time graph. So, distance is equal to area under the speed-time graph. Calculating the distance covered by a body from its speed-time graph. This speed-time graph represents the motion of a car over a period of 10 seconds. Calculate the distance traveled by the car during the 10 seconds. We know distance is obtained by calculating the area under the speed-time graph. Here we have to calculate the area of the shaded rectangle. And this area is equal to 40 multiplied by 10, which gives 400 meters. So the distance traveled by the car is equal to 400 meters. Calculating the distance covered by a body from its speed-time graph. This speed-time graph represents the motion of a car over a period of 20 seconds. Calculate the distance traveled by the car during the 20 seconds. We know distance is equal to area under the speed-time graph. Here we see we have a triangle. So the distance traveled will be the area of the shaded triangle. We calculate area of the triangle using the formula half multiplied by base multiplied by height. So the distance traveled here is half multiplied by 20 multiplied by 50, which gives 500 meters. Therefore, the distance covered by the car in 20 seconds is equal to 500 meters. Extracting information from a speed-time graph. A car accelerates from rest and moves in a straight line. It accelerates uniformly for 10 seconds until it reaches a speed of 20 meters per second. The car then travels at this constant speed for a further 20 seconds. Then it decelerates to come to rest in a further 10 seconds. So here we have the speed time graph for the car. Extracting information from a speed time graph. From the speed time graph of the car, we can obtain the following information. The nature of the motion. The car has uniform acceleration, then uniform velocity, and finally uniform deceleration. The value of speed at different times can be read. The acceleration and deceleration of the car can be calculated. The area under the graph gives the distance covered by the car. Calculating acceleration from a speed time graph. This speed time graph has three parts, namely A, B, and C. We see that only part A corresponds to acceleration, since speed is increasing only in part A. The values of speed for part A are read at different times. At time t is equal to 0 second, speed is equal to 0 meter per second. At time t is equal to 10 seconds, speed is equal to 20 meters per second. So, we are going to use a formula for acceleration. We know acceleration is equal to final velocity minus initial velocity over change in time. Here, the final velocity is 20 meters per second. The initial velocity is 0 meter per second. So we have 20 minus 0 over change in time. The change in time is 10 minus 0, which gives 20 over 10. So the acceleration is 2 meters per second square. Calculating deceleration from a speed time graph. We see that only part C corresponds to deceleration, since speed is decreasing only in part C. The values of speed for part C are read at different times. At time t is equal to 30 seconds, speed is equal to 20 meters per second. At time t is equal to 40 seconds, speed is equal to 0 meter per second. We know acceleration is equal to final velocity minus initial velocity over change in time. The final velocity here is 0 meter per second. The initial velocity here is 20 meters per second. So we have 0 minus 20, and the change in time is 40 minus 30. So we have minus 20 over 10. The acceleration is equal to minus 2 meters per second square. We see acceleration is negative, so we have a deceleration. We know deceleration is equal to minus acceleration. So here the deceleration is equal to minus of negative 2 meters per second square, which gives 2 meters per second square. So the deceleration is 2 meters per second square. Summary. In this lesson, you have learned about speed time graphs, types of speed time graphs, how to interpret speed time graphs, how to calculate distance from speed time graphs, how to calculate acceleration and deceleration from speed time graphs. Thank you for your attention.